All right, here we go. Chapter 5. All right, no more probability for a little bit at the end of the semester, but not a lot. So this section is a review section, really an Algebra 1 review. Okay, I'm going to kind of treat it like you guys don't really know much about it because you need this for a lot of stuff that we'll do this chapter and some of the coming chapters. So might seem easy for you. Just make sure, watch it. And then I have to write a lot of notes down, but these need to be a refresher on some things. So first off, standard form, okay, ax plus by equals c. So these are real numbers, not imaginary numbers. And just note, easy way, if it's in that form to get the x-intercept, take c divided by a. The reason why that is, x-intercept is when y is 0. So if that number is 0, that is gone. Solving for x, you would divide by a, right? Right. So x-intercept is c over a, y-intercept is c over b, right? In other words, just plug 0 in for whatever the other variable is, and that'll get it for you. And then note, as long as b is not 0, okay? If b is 0, okay, our slope's undefined, right? So if b is 0, what that looks like, let's just say if this is 3x plus 0y equals 6, okay? The y is gone. Okay, if we solve that line x equals 2, that is a vertical line, right? At 2, that is an undefined slope. Okay? If a is 0, you get a y equals, or y equals, like if it was y equals 3, that's a horizontal line, okay? So that's that. Okay, slope-intercept form, quick review. Remember, n is the slope, e is the y-intercept. Okay, slope formula, you will need this, right? Probably remember it, but if not, there it is. If slope is 0, it's a horizontal line. In other words, my numerator is 0. Okay, if it's undefined, it's a vertical line. Okay, undefined means you have like 3 over 0 or something like that. Remember, you cannot divide by 0. So that's undefined if that happens, in a vertical line. Then just note, remember, parallel lines have the same slope. Perpendiculars have opposite reciprocals, meaning like 3/4 and negative 4/3. Okay, flipped over negative, that's opposite reciprocal. Okay, point slope form, okay? I think you guys should have seen this. They used to not teach this in Algebra 1, they do now. I know I teach it in Algebra 2 also. So there's this way, or I kind of might do it often. I write it this way with the y1 on the other side. Doesn't matter though, whatever your preference is, okay? So quick example, if we're given a slope of -3, see n, point on the line, that's my x1, y1, just plug it in, okay? So I like this way better, so I'm going to show you this way instead of the other way. Same thing again, it's just if I added y1 over, okay? So all we do, plug everything in. So y1 is 5, slope is -3, so -3, x1 is 2, so -2. All right, so that's y1 and x1. Okay. And then if I needed to put this into slope-intercept form, all right, just multiply it out, just distribute, combine my terms. Okay. All right. These, we need to find the equation of the line going through these 2 points. Okay, we need to find our slope first. y2, not x2. So remember, it doesn't matter which one is your first point and second point. You can switch the order if you want. All right, if I do y2 minus y1, that'd be 10 minus 7. Okay, y2 minus y1 over x2 minus x1, so 7 minus 9. And x2 minus x1. So 10 minus 7 is 3, 7 minus 9 is -2, so -3/2 is my slope. All right, and then this is where point slope form helps. We can just pick whichever point we want. I'll just use the first point here. A lot easier to use this than, okay, when I was taught, I wasn't, back in high school, I wasn't taught point slope form. We were just taught slope intercept. We had to plug it in and then solve to get B. This is easier this way. So n is negative 3/2. Okay, x1, y1, we plug it in. You can use either point, doesn't matter. So x1 is 9, y1 is 7. All right, I could have used these as well to get the same answer. Okay. If we need this in slope-intercept form, we need to distribute it. I'll show this real quick. So it's negative 3/2 x plus, it's going to be 27 over 2. And then we need a common denominator. So 7 would be the same as 14 over 2. All right, combine our like terms, which are those two. All right, so that would be what, 41 over 2 minus 3/2 x. Oh, there's no y-intercept in my slope. All right, these, they look complicated, but really this problem here, okay, we're going to talk about it first and then I'll show you. So if I'm paving a parking lot, it says that if the cost is related to the area by a linear equation, we're going to use a linear equation. It says if it's the cost is of paving, so 1,000 square feet is $1,200. Cost of paving 1,500 is $1,600. We're going to find a cost of paving 1,600 square feet. So this problem, set it up basically the same thing as this one. All right, I'm given 2 points. Here's my first point, and then the 1,500 and 1,600, there's my second point. It doesn't matter which you pick as x and y, and you're going to get the same answer in the end. So generally, I would probably say cost would be your y variable. It doesn't really matter. You can still get your answer. But so really all we're doing though, we have this point. Okay, that's my area. That's my cost, the x and the y. And then we have the other point, 1,500, 1,600. All right, and then we just do the same thing. All right, we find our slope. So 1,600 minus 1,200 over 1,500 minus 1,000. So what is that? 400 over 500, which would be 4 over 5. And then for my equation, pick a point. Let's use the first one again. So 1,200 plus slope times x minus x1 would be 1,000. So I just used this point here. And then to answer the question, what's the cost of paving 1,600 square feet? Here's the part that people often mess up. Okay, that's my square footage. That's what I had as my area, that's my x. Okay, so just be careful with that. Make sure you plug it in for the right variable. So all you do, plug in 1,600, solve, get your answer. Okay. And that is it for this, for 5.1. Like I said, a lot of review. Let me know if you have trouble with it. Don't be shy about asking. I know it's been a while since you guys have taken some of this and done a lot of work with it. Next section is systems of equations. And then the third section is the hard one of the chapter, okay, which it's not horribly hard, but I don't think it's nearly as hard as probability stuff, but I think we can do it. So anyway, let me know if you have questions.